A snake's skin textures affect its movement. Atomic force microscopy and a structure function model help to unravel the locomotion of limbless animals. A Sidewinder rattlesnake. A Sidewinder rattlesnake, Crotalus cerastes. Credit. Victoroka, CC by SAW 3.0. Microscopic structures often influence macroscopic behavior in animals. For example, to learn how microscopic fasteners on a bird's wings improve its flight, see Physics Today, April 2020, page 20. For some Sidewinder snakes, the microstructural patterns on their skin create a highly frictional interface with the ground. That enables the snake to generate a large propulsive force perpendicular to its direction of movement. Jennifer Reeser of Emory University in Atlanta, Georgia, Ty DeLee of City University of New York, and their colleagues recently took a closer look at those microstructures. The researchers have now developed a model that uses the morphology of animal skin structures to predict a preferred movement direction. The scans below from atomic force microscopy show the structural features on the underside of a single scale for two species, a non-sidewinder snake, Chianactis occipitalis, and a sidewinding viper, Crotalus cerastes. The microspikes of Ch. occipitalis, left, form an anisotropic texture that contrasts with the pitted, more isotropic texture of Cr. cerastes, right. Microscope scans of two scales figure courtesy of J. Reeser et al. Proc. Nadel. Acad. Sci. USA 118, E2018264118, 2021. A two-dimensional power spectrum of the scans reveals that the strongest peak of the non-sidewinder scale is oriented along the horizontal axis, which corresponds to the y-axis oriented microstructure. The spectrum of the sidewinder, on the other hand, is radially symmetric. Those structural differences, the researchers argue, are responsible for the differences in how the snakes move. To learn more about the structure-function relationship, Reeser and her colleagues divided the underside of a model snake into segments to see how the interactions between each segment and the ground surface affect the animal's forward motion. For the non-sidewinder snake, the model produces a highly anisotropic friction as the animal moves forward via lateral undulation. But for the sidewinder, anisotropic friction leads to a backward slipping motion that hinders its forward progress. The case with no anisotropy generated the largest forward displacements. The researchers are next interested in exploring how movement may be affected by the softness of the skin, the mechanical properties of the ground surface, and whether muscles activate particular skin patterns. J. Reeser et al. Proc. Nadel. Acad. Sci USA.